All right. Good morning, everyone. Is everyone excited about this project? No? Well, I'm very excited about this project because I really wish I had this when I started learning about networks. Because how I learned about this like computer networks is pretty much similar to what many people had done. Basically, we go from theory, from books, and then we have a set of exercises we practice with. Then we have a lab session where we have a few network devices and a lot of people cramming into a room and try to configure them because they're expensive devices and pretty hard to deal with. But in practice, it's not the case, right? As Maria has introduced, the internet is a network of networks. It's a collective effort. So network operators typically meet very frequently and to discuss peering policies and to make business deals with very strict service level agreement. And debugging is pretty tricky when you have thousands, hundreds and thousands of lower level devices connected with each other. And the internet is the biggest distributed system on Earth. Right? This is kind of a mailing list where the network operators were discussing like what was the problem with the AT&T network. And also, we have thousands of autonomous systems or thousands of networks, and we need to continue monitoring them and to make sure that we have network-wise connectivity. And this is pretty tricky. And this is something called connectivity matrix. So each row and each column is an AS, and each cell is telling you the connectivity from the row AS to the column AS. Let me know if you have any questions, just raise your hand, okay? Right, so that's why we've been preparing for you this exciting project. And the goal is to mimic how the real internet works. So creating this kind of microcosm of this project, the environment for you, and let you experience what it feels like to be a real network operator. So this is the AS topology we've built for you. So we've deployed 60 ASs, so 60 autonomous systems in total in 6 areas or 6 zones. And each of you or each of your group is operating a transit AS. By transit, I mean you have two providers from which you are getting service, and you have two customers that you need to provide traffic for. And also we provide one IXP between every single zone, which means that you don't really need to rely on your provider to reach certain activity. Maybe your providers are, having a midterm or something. You have a question? Okay. And also at the end of each zone, we also have malicious ASs where we will launch BGP hijacking attacks. This is where once you have global connectivity, we'll see how fragile the internet actually is, and show like how like a specific one leaking or malicious advertisement can really ruin the whole connectivity matrix. And the internal topologies within HES are also built with real-world technologies. So L2, like each AS has an L2 network with switches and hosts. We're using Open switch. And the L3 network are built with FFR routing with routers and hosts. So each network device, either it's an L2 switch or L3 router, has hosts connected to it. And the command line interface we're using is very similar to the Cisco devices if you've used both. And you should have no trouble transferring what you've learned in this course to actual practice to interact with real devices. So this is the L3 topology in practice. With build, I won't delve into the details. I will let you read the documentation. But we try to map like a real geographically located cities to the router locations. And for example, here, NYC, Chicago, and San Francisco, these two cities were the one or three out of the four initial network access points in the 80s. Okay. And all those cities are big data center cities, locations. This is the L2 topology. So it's the hospital networks. And each network has two VLANs. So they are physically connected to one broadcast domain, but you need to separate them into two logically separate LAN network, local area networks, one for the patients, one for the admins. And your job as a network operator is not easy. Right? That's why we give you 4 weeks of time. So first, the first part of this project, you need to enable internal AS connectivity, meaning that within your autonomous system, you should have connectivity by configuring L2 spanning trees among those switches, VLANs, OSPF, routing, and traffic engineering. For example, here, we always prefer the high bandwidth path if we were communicating between C and E. But we still want to keep the low latency path between E and D. After that, we'll move on to enabling internet-wide connectivity, meaning that you guys will communicate with each other and talking about the policies, routing policies you all have, and establish external and internal BGP sessions. And BGP is so important. So we have a lot more stuff to play with. So after that, you can configure pairing policies. So the internet is, as much about technology as it is about policies and business. So there are pairing agreements, and for example, you shouldn't export certain routes to given the role of that AS, right? If that AS is your provider or peer or customer. And we will optimize the performance in terms of latency of BGP path because typically it doesn't select the shortest path, right? It's based on the policies operators define. And you guys need to prevent hijacking attacks as well. Okay, for example, here between these two providers, you've got to choose one of the two based on your policies. So this is so-called multi-homed autonomous system. It is a challenging task. That's why we've provided you with a slew of tools. The first of all is the connectivity matrix. So it's like the real-world connectivity matrix that network operators have access to. And so at the beginning of the project, the matrix should be kind of red, right? Because only those automatically configured ASs will have internal connectivity. After the first part, you should have internal connectivity, meaning that the diagonal should be lit up. I should explain what those cells means. So here, if we look at one of the cells, say like row 31 to let's say 13. So row 31 to column 13. It means that if it's red, it means that it doesn't have AS31 doesn't have connectivity to AS13. So you read this one, well, in this direction. If you put your mouse, if you're hovering your mouse on top of the cell, you'll see the explanation. Green means yes, you have connectivity, and actually we have another color if you go to the website. It's orange. Orange means that you have connectivity, but you are the route is wrong. So you are reaching, for example, your destination through an invalid path. So it's violating some pairing agreement. Any questions? Yeah.
What's like an example of like an invalid path if it's still able to reach? shouldn't that be gonna be a path that works? And that
Right.
be valid?
Right. So the question is, like, why do we still have connectivity if we have invalid path? Right? So invalid path should not give us connectivity. Is that the question?
Yeah.
Um, yeah. So I should clarify that validity is not connectivity. So validity is in terms of policies. So policy and connectivity are two things. You can reach me, you can talk to me, for example, via Maria, but that's the wrong path. You should talk to me directly. To give you a direct example, so if you, as a customer, you're well, you are reaching your, I don't know, peer through your provider. So later, you will see in later lectures in BGP related to BGP. This is a policy violation. You can still have the reachability, but this is a violation of policy. This is because you are not paid to carry the traffic for certain ASs. Yeah.
Perfect. Thank you.
Sure. Good question. Any other questions? No. Right. And also there is something called looking glass. So the internet is so big, right? It's very difficult like for any single person to get a full picture of everything. So we have something called looking glass through which you can pick into an AS to get a sense of what kind of routes the autonomous system is advertising and receiving. And so that you can see the policy violations and adjust your configuration accordingly. And this is a crucial tool, also helping you in one of the pairing sessions we'll have. And we'll provide you with a measurement node from which you can shoot pings, launch trace routes from any AS to any other AS, meaning that you can test connectivity from anywhere in this topology with DNS enabled, meaning that you don't need IP addresses. You can just name like which group you want to ping. And we provide you with very detailed tutorial. So in this case, like how to use the command line interfaces of those devices. It's all there. If you have any questions, please post on ad as well. Right. The most exciting part, I would say, is the networking party or the hackathon, where you will experience as a real network operator how like you guys communicate with each other about your policies, like the IPs you've got to use at the border routers and so on. And yeah, that would be very exciting because it's a collaborative effort. Whether we can, the goal would be reaching 100% grain, the connectivity matrix, right? Hopefully we will get there at the end of the session or the project. Yeah, so a few last points. If you have any questions, please post on ads and discuss your confusions there, and we'll collect your questions on ads, some common questions, and then we'll also discuss those problems during the lecture. And today we'll distribute the credentials through emails so that you can access your devices and the repository. All right. Any remaining questions? Nope. Okay. Thanks.
Thank you, Hong.
Sure.